Hello guys. In this video I would like to teach you on how to do differential equation using operator d. Okay, so we're given a d squared minus 5d plus 6 equal to 3 and e to the power of 4x, and y at 0 is equal to 1 over 2 and y prime at 0 is equal to 12. Okay, so before we solve this problem, I would like to teach you on how to approach using a theorem 1, because I haven't teach you on how to do the theorems. So on this video I would also like to touch on how to do theorem 1. Okay, so theorem 1, when we are given y equal to 1 over a function of d times or on reaction of a times e to the power of a x. Okay, so if we have something like this, and therefore the answer will be, we take this e to the power of ax to this side, so we will have e to the power of ax and then times 1 over, okay, so where there is d we put a, which is this coefficient of x, not this one but this small letter a. Okay, on d, where we see d we put the small letter a, so we have the function of a, and then we are left with a action on a. So this is how we solve theorem 1. This is how we approach theorem 1. Maybe let me take an example. Let's say we have 1 over d squared minus d and plus 1. Okay, action on 3 and e to the power of 2x. Okay, so it's y. So our first step is to bring this e to the power of something on this side. In this case it's e to the power of 2x. Okay, and times 1 over, where we see our d, we put our coefficient of a, which is in this case is 2, so we say 2 squared minus 2 plus 1 action on 3 on this side, which is what will be left. Okay, so we say y equal to and e to the power of 2x, so it is just only the simplification. So 2 squared is 4 minus 2 is 2 plus 1 is 3, so we'll have 1 over 3 action on 3. Okay, so this one will cancel each other, and therefore we have our solution, which is e to the power to the power of 2x. Okay, so this is how we solve the theorem 1. Okay, so on this side I would like to do this problem. Okay, so it is a d squared minus 5d plus 6 equal to 3 and e to the power of 4x, and we also given the condition that is a y at 0, which is equal to 1 over 2, and y prime at 0 is equal to 12. Okay, if I may bring this here so that you can see. So it is a DE using operator D. Okay, all right. So our first step here, when we approach or when we are given this, is to first find the AX equation. The AX, I call it an AX equation or an X equation. And an X equation, it's where we take this and equal to 0, but now it is no longer d, but it is m. So instead of d, we put m. So we will have m squared minus 5m and plus 6 and equal to 0. Okay, so this is an x equation, and we open our bracket so that we solve for m, and therefore we'll have m, and this is 6 and this is 5. So what makes or the factors of 6 is 3 and 2. So 2 times 3 is 6 and 2 plus 3 is 5, and therefore the signs will be the negative, and therefore our m is equal to 2, or m is equal to 3. Okay, and now we have our solution on x equation, and therefore now we need to find the complementary function. The complementary function, so basically this is step number 1 and this is step number 2. Okay, so the complementary function is in this form: y is equal to e to the power of m1 x and plus b e to the power of m2 and x. Okay, so it may be differ if you have your values repeated. Maybe, for example, if you have m equal to 2 and m equal to 2. Okay, so it will be differ in that case if your m is repeated or twice, and therefore your function should be in this case in this form of y equal to a and e to the power of m1 x and plus a bx and e to the power of m1 and x. Okay, so in this case they are different, so we will have something like this. Okay, so we have m1 which is and 2 and m2 which is 3, so we just need to substitute, and therefore we have our complementary equation. Therefore we have a y equal to a and e to the power of 2x and plus b and e to the power of 3x. Okay, and therefore this is our complementary equation. It's nothing that is hard, just you just need to know on how to do a DE using the operator D. Okay, and then we need to find the particular function. The particular function, it is a y, which is a particular function, is equal to 1 over the function of d on action or f at x. Okay, so when we have something like this, which is slightly similar to theorem 1, but depend on the cases. Okay, all right, so we have our y pf will equal to and 1 over our function d. It is this at d squared minus 5d plus 6. Okay, so we will have a d squared minus 5d and plus plus 6. Action on everything on this side will be our f at x, so we will have action on 3 and e to the power of 4x. Okay, all right, so we need to apply now a theorem 1 to solve this one. As you can see, we have similar thing. Okay, all right, we will have y pf equal to, then we bring e to the power of 4 x on this side, and then 1 where there is a d, we put our a, which is in this case is 4, so we say 4 squared minus 5 and 4 and then plus 6. Okay, and then action on 3. All right, So now we have a y particular function equal to e to the power 4x, and then we have 1 over 4 squared is 16, and we also have 5 times 4, which is 20, and therefore we have 36, and then we have plus 6, then 36 plus 6, which will be 36 plus 6, it is 42. Yeah, it's 42. It must be 42. So it's 42 action on 3. Okay, but let me confirm using my calculator. Where is it? Okay, I don't have it. Okay, here is it. Right. Okay, so it will be it's 4 squared minus 5 and times 4, and then plus 6. Okay, this gives me 2. All right. Okay, no problem. Oh, there is minus. I was adding, so it will be 16 minus 25, not plus. Okay, so instead of 42, it will be 2. All right, so we have our y pf equal to, and then we have our 3 and e to the power 4x over 2. So this is our particular function, and therefore on now we can have our final answer, which is our general solution, which is in the form of y equal to a y of a complementary function, it's complementary function, and then plus the y, which is for the particular function. All right. Okay, and therefore we have our general solution to be a e to the power of 2x and plus b, and e to the power of 3x and plus 3 over 2, and e to the power of 4x. Okay, so this is our solution. But now we are also given that we y at 0 is equal to a half, and y prime at 0 is equal to 12. Okay, so this means we need to find our value of a. We also need to find our value of b. Okay. So let me start over maybe on this side. Okay, so we have this general solution, which is a and e to the power of 2x and plus a b and e to the power of 3x and plus 3 over 2 and e to the power of 4x. Okay, and we have y at 0 is equal to 2. So this basically means that x is equal to 0, and where x is equal to 0, and our y will be 1 over 2. And also x is equal to 0, but now our y prime will be at 12. So okay, so we need to just substitute our half here equal to an a and e to the power of 2, and but now our x is 0, so we substitute, and then plus a b and e to the power of 3 into 0, and therefore we have plus 3 over 2 and e to the power of 4 into 0. Okay, so we have 1 over 2 equal to here it will be a, because e to the power of naught is 1, and plus a b and e to the power of same thing. Okay, then we have also plus 3 over 2. Okay, so 3 over 2 is just 1 over 2. If you transpose, it will be 1 over 2 minus 3 over 2, which is negative 1. So on this side we'll have a negative 1, equal to a plus and plus b. So this one will be our first equation. Okay, and then we need to find a derivative of this general solution here. So if we can derive here, we will have a derivative of y, and if we derive e to the power of 2x, it will be 2a and an e to the power of 2x, and on this side we'll have a 3b and e to the power of 3x, and also plus on this side we'll have it will be 4, then it will be 6. So the two will cancel other 2, and then we will have 3 times 2 that will be left, which will be 6, and we have our e to the power of 4x. Okay, so but now we are told that our y prime is 12, and if it's 12, 2a, and therefore here it will be a 2 at 0 and plus and 3 at b, and e to the power of 3 at 0 and plus and 6 and e to the power of 4 at 0. Okay, so we have 12 equal to here we'll be left with 2a, since this one will all become 1, and plus, and this one will have 3b since this one will become just 1, and then plus 6, and therefore we just say 12 minus 6, it will be 6, and equal to 2a plus 3 plus 3b. Okay, so this is our 2, and therefore we have our equation 2, and we can just simply manipulate this one. It will be a negative 1 a minus b equal to a. So then we take this one and substitute here, so we will have something like this. Okay, sorry, we'll have something like this. 6, we have 6 equal to where there is a, we put this one, so it is negative 1 minus b, and plus 3 and 3b. So we have 6 equal to negative 2 and minus 2b, and plus 3 3b. Okay, right, so we have this one will be 8 and equal to if we transpose, and this one will be b. So our b is equal to 8, and therefore our a will be equal to negative 1 minus our b is 8, and a is equal to negative 9. So this is how you solve it. But now if you are not given this condition, and therefore you are not supposed to find, or you are not supposed to stress yourself finding a b and an a, so you will be required to have something like this, which is the general solution only. So thank you. Please, if you like this video and if you benefited on this video, please subscribe on my channel and like the video. Comment on the section maybe if I did made an error, so we can correct it. So thank you. Have a good night.